Imagine looking up at the night sky, dreaming of reaching distant worlds. For decades, chemical rockets fueled our ambitions, but progress was slow. Today, March 25, 2026, NASA unveils a plan that could redefine our place in the universe. The SR-1 Freedom mission isn't just another trip to Mars, it's a leap powered by nuclear energy. This ship, unlike any before, uses atomic power to shrink the solar system, making Mars more accessible than ever. For generations, a journey to Mars meant months of exposure to deep space hazards. Nuclear propulsion could cut that time dramatically, transforming a 9-month ordeal into a sprint of just a few months. This isn't just about speed, it's about safety and making Mars a real destination for humanity. The age of interplanetary travel is no longer a distant dream, it's on our doorstep. SR-1. Freedom is more than a spacecraft. It's a symbol of our relentless curiosity and drive to explore. The next chapter of humanity's story is being written across the cosmos. So, how does a nuclear-powered spaceship work? At its core, SR-1 Freedom uses nuclear thermal propulsion. A compact fission reactor heats liquid hydrogen, blasting it out a nozzle for continuous thrust. Unlike explosive chemical rockets, this system provides a steady, efficient push, allowing the ship to accelerate for much longer. Safety is paramount. The reactor stays cold during launch and only activates in space, far from Earth. This design ensures no radioactive risk to our planet. The real advantage: efficiency. Chemical rockets burn fuel fast and coast. Nuclear rockets keep pushing, using fuel far more effectively. This means higher speeds, longer missions, and lighter spacecraft. SR-1. Freedom can travel farther with less propellant, making ambitious missions possible. It's a technological leap that changes what's possible in space. Picture a race to Mars. Chemical rockets versus SR-1 Freedom. Chemical rockets are powerful but burn through fuel in minutes, then coast for months. SR-1 Freedom, once in space, fires its nuclear engine for weeks, gaining speed steadily. The key is specific impulse. Nuclear rockets get at least double the efficiency of chemical ones. That means faster trips or more cargo. For Mars missions, this is a game changer. More supplies, bigger habitats, and advanced labs can be sent. Every kilogram counts with chemical rockets, but nuclear propulsion opens the door to sustainable exploration. It's not just about planting a flag, it's about building a future. With SR-1 Freedom, Mars becomes more than a destination. It becomes a place we can truly explore and settle. The tortoise, with a nuclear jetpack, finally wins the race. This is the dawn of true planetary settlement. The mission transforms from a daring expedition to the first steps of a new civilization. SR-1. Freedom isn't traveling alone. It carries the Skyfall Mission, a fleet of robotic helicopters. Instead of one rover, dozens of advanced drones will explore Mars from the air. Each helicopter is a flying lab, equipped with cameras, sensors, and radar. They'll cover thousands of square kilometers in weeks, reaching places rovers can't. This swarm approach gives us a comprehensive, high-resolution map of Mars' geology and climate. Working together, they'll scout for resources and identify the safest, most interesting landing sites for humans. The data they gather will be crucial for future explorers, mapping terrain, finding water, and paving the way for human missions. It's the ultimate reconnaissance, a robotic vanguard preparing Mars for humanity. The Skyfall mission revolutionizes how we explore, turning Mars into a world of opportunity. The future of planetary exploration is a swarm of eyes in the sky. SR-1. Freedom's nuclear engine is more than a shortcut to Mars. It's a gateway to the solar system. With this technology, destinations like the asteroid belt or Jupiter's moons become reachable. Nuclear propulsion could enable a steady supply chain, supporting permanent colonies and new civilizations. But with power comes responsibility. Managing nuclear materials in space raises ethical and safety questions. We must ensure these systems are used wisely, with transparency and international cooperation. The cosmos is a shared heritage, and our expansion must be guided by foresight. SR1. Freedom is more than a ship. It's humanity's bold question to the universe. As we stand at this crossroads, we must ask, is this the moment we truly begin our journey to the stars? The future is waiting. Will we answer the call?